In these next few examples, we're going to be adding and subtracting, and then even simplifying some more complicated fractions that look like this. So we'll be doing 6 examples here in this segment. So what we're going to do here, when we add or subtract, we're going to factor, and then we're going to determine the least common denominator, and then we're going to get a common denominator by multiplying the top and bottom of each term by the needed factors. And then we can do our addition and subtraction since we have a common denominator. So this is the same as what you learned back in middle school, where to add or subtract fractions you need a common denominator. We're just now dealing with polynomials in our denominator. There's really nothing to factor here, so we don't have to do that. So that's checked off. Determine the least common denominator. Well, we need the whole denominator, the whole factor here. So it's going to be a plus 2 I need, and an a minus 2. And so what I'm going to do over here, I need the a minus 2, so I'll multiply the top and the bottom, the numerator and the denominator, by a minus 2. Over here I need the a plus 2, so I'm going to multiply the numerator and denominator by the a plus 2, because that's just multiplying by a form of 1. So up in the numerator here, we'll just, actually let's mention this, we now have a common denominator of a plus 2 times a minus 2. I'm going to leave it in factored form right now, because sometimes there is a chance that things could factor and simplify. Here we have a 6a minus 12 plus, I'm going to put parentheses here, although in this case it's a plus, we don't need it, but I'm going to try to get in the habit of doing this so when it's subtraction we don't mess up. So we're going to distribute the 3, and we get 3a plus 6. Now we can add, again, these parentheses weren't needed because of this addition sign. So we have a 6a plus 3a is 9a, and negative 12 plus 6 is negative 6. And we have a plus 2 over a minus 2. This answer is acceptable. Since I would factor out a 3 since these are factored. Factor out a 3 just to see if we can simplify anything, and we get a 3a minus 2, which does not simplify with either of the factors in the denominator. So our answer remains like this. Next one is another addition. We're going to go ahead and factor the 4k minus 4. We can factor out a k, and that's a 4 times k minus 1. And now we can look for our least common denominator. Now looking at our constants, a 2 and a 4, the least common denominator of 2 and 4 is 4. And then we have this k minus 1. So our least common denominator ends up being this denominator right here. So what we're going to do now is we're going to get a common denominator. Over on this side, we have a 2 in the denominator, but we need a 4k minus 1. So in order to get the 2 to be like a 4, we need another 2. And then we need that k minus 1. That will get us our common denominator of 4, because 2 times 2, times k minus 1. What we do to the bottom, we're going to do to the top, because it's like multiplying by 1 there. And so in the numerator, we have this 10k minus 1 plus 6 from here over our common denominator of 4k minus 1. Again, some of you think, oh, I have a k minus 1 and a k minus 1. We cannot cancel there because of this addition sign. If they were all multiplied together, that's fine, but they are not. So now let's distribute the 10. We get a 10k minus 10 plus 6 over 4 times k plus 1, k minus 1. We can combine these two. So we have 10k minus 4 over 4k minus 1. I'm noticing here we have a 2 that we can factor out. So this is 2 times 5k minus 2 over 4 times k minus 1. And now we have a 2 here and a 4 here, and 2 goes into both of those, so that reduces to 1 and a 2. And so now we can write our final answer as 5k minus 2 over 2 times k minus 1. Here's one with subtraction. Again, we're going to factor. So this we can factor out a 3x, and that leaves us with 2x minus 5. So our least common denominator needs a 3, because both of these have a 3, needs an x, and then the 2x minus 5. And so if that's our least common denominator, we're going to need to, so we can get rid of this, multiply the left term. We don't need the 3 because we already have it, but we do need to multiply multiply by 2x minus 5 in both the numerator and denominator to give us our common denominator. And so now we have that common denominator of 3x 2x minus 5. Up here in the numerator, we have a 4x squared times 2x minus 5 minus, and here's why it's important to put this in parentheses, because this negative will be distributed. So over here, we have 4x cubed minus 20x squared minus x, because we're distributing this negative, and then plus 5. And in the denominator we have 3x and a 2x minus 5. And there's another subtracting one. Our last subtraction one, we have a denominator of here. We can go ahead and factor that. This is going to be an x minus 5 times an x plus 1. The reason we factor early is because sometimes we might be able to cancel something in the numerator with denominator. We can't here because this is a plus 1 and this is a x minus 1, but that is why we factor first. There's only this denominator here, so that's what we need. So multiply top and bottom by that. So what I'm going to do here, I'm going to put a 4, and then I have x minus 5 times x plus 1. Well, that came from this, so I know that 4 is going to be multiplied by that. And then minus the x minus 1. That's all over our common denominator of x minus 5 times x plus 1. We'll distribute our 4 up on the numerator, so we have a 4x squared minus 16x minus 20. This negative gets distributed, so negative x, and then a plus 1 over the common denominator of x minus 5, x plus 1. And then we have a 4x squared minus 17x, and then minus 19, all over x minus 5 times x plus 1. And that's our answer. Sometimes you do want to check if you can factor this. This one I don't believe factors, so we can leave our answer like that. Example 15. This one takes a couple steps, because what we're going to do here is we're going to add these two, because there's a sum of fractions within the fraction. So we'll add these two, and then we'll simplify that compound fraction. And so in order to add these, we need a common denominator. This has an x, this has a 25. So this needs an x over x, because we need the x in the denominator. This needs the 25 over 25. And so we'll put it over here. We still have the 1 over x over, now we have our common denominator of 25x. So we'll put 25x here, and then we have 25 plus x cubed. And from there, we're actually back to an older one. We see this is a 1 over x divided by this part here. Well, we know that dividing is the same as multiplying by the reciprocal. So I'm going to multiply by the reciprocal of this. That'll put the 25 over x in the top, and then 25 plus x cubed in the denominator. This x reduces with this x, and we get 25 over 25 plus x squared. And our last one for this part is another one similar to that. In this case, there's a fraction or a sum of fractions in the numerator, so we're going to add those. Our common denominator of these two is this one needs a 5, and this needs a u plus 2. So we'll multiply the top and bottom by 5 here on the left term, and we'll multiply the top term by u plus 2. That gives us 80 minus 1 times u plus 2. Make sure you're careful about the minus. That negative will get distributed over 5 u plus 2 over 16. I'm going to go ahead and simplify the top here. This is 8. 80. This negative will get distributed. So we actually have like an 80 minus 2, which is 78, minus u over 5u plus 2, all over 16. When we're dividing by 16, that's like multiplying by the reciprocal of 16. So we're going to have 78 minus u over 5u plus 2, multiplied by the reciprocal of 16, which is 1/16. And we get 78 minus u in the numerator equals 80, because 16 times 5 is 80, u plus 2. And there's your answer. You could have also multiplied the 80 through that binomial and got 80u plus 160. I'm fine with either of these answers. So